Hello viewers, I am Kausalya. Today we are going to solve problem 7 in exercise 13.3. So the problem is a cylindrical bucket 32 cm high and with radius of base 18 cm is filled with sand. So here we have a cylindrical bucket whose height is given and whose radius is given. This bucket is emptied on a ground and a conical heap of sand is formed, right? So just as we form on the beach. So if the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So here there is a cylinder whose parameters are given. Now the sand filled in the cylinder is now dropped down to form a cone. So here this is our cone and whose height is given. So here we have to find the radius and slant height. So for the cylindrical bucket, the radius is 18 centimeter and the height h1 is 32 centimeter. And for the cone, the height h is given, it is 24 centimeter. So again let R1 and H1 be the radius and height of this cylindrical bucket and R2, H2 be the radius and height of the cone. So obviously the volume of this cylinder should be equal to the volume of the cone because the sand which is filled in this bucket makes this cone. So volume of this cylinder should be equal to the volume of the cone. So what is the formula? It is pi r square h and here volume of the cone is 1 by 3 pi r square h. So here it is R1 H1 and here R2 H2. So now for this cylinder we know all the values, so just substitute it here, whereas for the cone we know only the height h, the value R2 is unknown. So just keep it as R2. So here it is pi 18 square into 32 and here it is 1 by 3 pi, we don't know R2, so let it be R2 here. So R2 square into the value of height is 24, so just write it as 24. So here pi and pi cancel each other and 3 and 24 they cancel by 8 times. So here we have 18 square into 32 which is equal to R2 square into 8. Now we need the value of R2. So here I am moving this 8. So this 8 when moved to the left hand side, it occupies the denominator part. Now 8 and 32 they cancel by 4. And again you see here I am having 18 square, that is 18 into 18 into 4. Right. So immediately don't multiply and try to take a square root to find R2. So here you see we have 18 into 18. So it is 18 square and this 4 can be written as 2 square. Right. When you write like this, it is very easy for you to take the square root. So here we need only R2. Right. So when you take square root on both sides, you see 18 square becomes 18 and 2 square becomes 2 and R2 square becomes R2. Right. Because when you take square root, that is 18 square into root 2, this square and this root 2 they cancel, so that we will be having 18. So 18 into 2 is nothing but 36 centimeter. So this is the value of R2. Now we have to find the another parameter which is the slant height of the cone. So in this diagram what is the slant height? This length, okay, this is known as the slant height of the cone. So the formula is L is equal to square root of R2 square plus H2 square. So what is the value of R2? It is 36 and the value of H is given which is 24. So 36 square plus 24 square, it finally gives the answer as 1872. That is square root of 1872. So to find the square root of 1872, you see, you just solve by taking the least number. Here it is an even number, so I start dividing using 2. So when I divide, I am getting 936, again 468 and again 234. So again 117. Now this 117 cannot be divided by 2, so I go to the next number 3. So it is divided by 3. And finally, you see here we have the following factors. So now these terms can be written as, you see, 1, 2, 3, 4. I am having 4 2's. So which can be written as 2 square into 2 square, right? That is 2 to the power 4 can be written as 2 square into 2 square. And again, I have 2 3 terms, so 3 square into 13. Now, when you take the square root, you see this 2 square become 2, again this 2 square become 2, and this 3 square become 3, and root square root of 13. So now 2 2's are 4 and 4 3's are 12. So here the answer is 12 root 13 centimeter. So this is the slant height of the cone which is formed. Now, if you want, you can find the square root of 13, which is 3.6, which gives the answer as 43.2 centimeter. Now, finally, the radius of the cone is 36 centimeter and the slant height is 43.2, or you can write it as 12 root 13 centimeter. Okay, here both are correct. Now, we will proceed with our next problem. Problem number 8. So, water in a canal 6 meter wide and 1.5 meter deep is flowing with the speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? So, here there is a canal whose width is 6 meter and depth is 1.5 meter. And can you guess what is the shape it is? First, let me show you how a canal looks. So you see, this is a canal. So this canal, what are all the things which is given? The width is given. The width is given and the depth. Okay, and the here depth, how depth the water is. So here we are provided with two parameters. Okay, one is width and another one is depth. So obviously we don't know how much length it is. So what is the shape that has length, width and breadth? Obviously it is a cuboid. Right. So here first I start our discussion with the speed. So the speed is given as 10 km per hour. So here for 1 hour it is 10 km. Therefore converting this hour to minutes, because we need 30 minutes. Okay, how much area will it irrigate for 30 minutes? So I need only for 30 minutes. Therefore, so 1 hour is nothing but 60 minutes, but I want 30 minutes. So how to get 30? Just divide it by 2. So when you divide both sides by 2, and you see I had converted this kilometer to meter. So obviously I am dividing this by 2. So 30 minutes is equal to 5000 meter. So this is the length of the canal, right? So they had given us with the width. They had given us with the width and depth. They didn't mention about the length. So to find the length, we had made this as a clue. 10 km per hour. So from this we have calculated what is the length. So here the length is 5000 meter. Therefore, the volume of the canal, as I just said, it is a cuboid. Therefore, here it is L into B into H. Since everything is in the form of meter, that is the main reason why I had converted this kilometer to meter. So, it is 5000 into 6 into 1.5, which is 45,000 meter cube. So, this is the volume of the canal. Now, here we have to find the area. Okay, how much area will it irrigate if 8 centimeter of standing water is needed? So let me tell you what is standing water. So here we don't know the area. Okay, it may be of any kind, it may be of any shape. But the hint which is given here is it has a standing water of 8 centimeter. For example, I am considering this as an area and it has a standing water of 8 centimeter. So here What is the purpose of standing water? Generally in rice fields, we can see the standing water. In the initial stage, there must be a standing water. So here you see, we don't know the area, but it has a standing water of height 8 centimeter. So area to be irrigated, I am writing it as there may be some area. I don't know what it is. No shape is mentioned. So area, but it in that area it should have a standing water of 8 centimeter, which indirectly means that it is the height h. So here it is area into h, therefore here area into 8 centimeter. But in the previously we have each and every dimensions in the form of meter. So here I am converting this centimeter to meter. So I am dividing it by 100. Therefore here it is area multiplied by 0.08 meter. So you see, name this as equation 2. Here this is the volume of the canal. So depending upon the volume of the canal, the land will be irrigated. You say yes or no. Depending upon the volume. For example, I am still make it you in a simpler way. You have 1 liter water bottle. So totally you have only 1 liter of water. So depending upon the 1 liter of water, you can fill, for example, I am telling 1 liter of water can fill 10 tumblers. For example, okay, 10 glasses. If you have only half a liter, then obviously it can fill only 5 glasses. Say yes or no. Similarly, that is the thing why I am relating this volume to the area to be irrigated. Okay, the volume is just like our water bottle. And area to be irrigated is just like filling the glasses. So here volume of the canal is equal to the area to be irrigated. That is the main reason why I am equating this volume of the canal or equation 1 with equation 2. So volume of the canal is 45,000 meter cube, and here area to be irrigated is area into 0.08. Again you see area will be having a unit of meter square, and here it is meter. So meter square into meter will make meter cube. So finally you see, to find the area, I am moving this 0.08 to the left hand side. So here it is in the denominator part. So in order to remove the decimal point, you see after this decimal point I have 2 digits. So I am multiplying and dividing by 100. So what happens here? It becomes 45,000, then another 20. So it becomes 45 lakhs divided by 8. So here the unit is meter cube and area it remains as such, and for this side, that is for this height, it is meter. So they cancel and they become meter square. Therefore the area is 562500 meter square. If you want to find the area in hectares, then you have to divide this value by 10,000, because 1 hectare is equal to 10,000 meter square. Therefore, it is 56.25 hectares. Right. We will proceed with our last problem. Problem number 9. The problem is a farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? So here we have a pipe of internal diameter. Okay, there is a pipe. Okay, let this be your pipe whose internal diameter is 20 centimeter, and this pipe fills a cylindrical tank. You see here a cylindrical tank, and whose parameters are, whose diameter is 10 meter and whose height is 2 meter. Now the water which flows through this pipe is given at the rate of 3 km per hour. So we have to calculate the time at which the tank will be filled. Can you understand the question? We have a pipe, we have a cylindrical tank. The water which flows through this pipe is at the rate of 3 km per hour. So here we have to find at how much time will the tank be filled and the parameters of the tank are given. So first we start with the calculating the dimensions. So here regarding pipe, the diameter is given, and again you see here it is in centimeter and here it is in meter. So now I am going to convert this centimeter to meter. So obviously dividing by 100 gives me 0.2 meter. So this is your diameter of the pipe. Therefore the radius is 0.2 by 2. Here it is 0.1 meter. Now we proceed with the cylindrical tank. Again the diameter is 10 meter. Therefore the radius is 5 and the height is 2 meter. Now the basic concept again here is the volume of the pipe should tally with the volume of the cylinder because this is the pipe that fills the cylinder. But here we know only the radius, we don't know the length. So what we are doing here is we are equating the volume of the pipe to the volume of the cylinder to find the length of this one. Again, when you look carefully, this pipe is also a cylinder, right? This is also a cylinder. So now we are going to equate the volume of the pipe to the volume of the cylindrical tank. And both are cylinders. Always keep this in mind. So volume of the pipe is equal to volume of the cylindrical tank because the water flowing through this pipe fills this cylindrical tank. That is the main reason why here we are equating the volume. So formula is pi r1 square h1 and here pi r2 square h2. So here you just write it initially. Okay, let this be the parameters related to pipe are r1 and parameters related to this cylindrical tank are r2 and h2. So now just substitute the values. So this pi and pi they cancel each other and I need to find the h1 which is nothing but length of the pipe. So here the length of the pipe is given as, you see 5 square into 2, I am moving this. So here it becomes 0.1 into 0.1 which occupies the denominator part. So to remove the decimal point, you see after this decimal point here one digit and here one digit. So I have to multiply by 100. Therefore I am multiplying and dividing by 100. So 25 into 2 is 50 and 50 into 100 becomes 5000 meter. So here the length of the pipe is 5000 meter. So when I convert this to kilometer, it becomes 5 kilometer. Now here we need to calculate the time at which the tank get filled. So the speed is given as 3 kilometer per hour. What does it mean? That is for 1 hour 3 kilometer. So what happens for 1 kilometer? You have to move this 3 here. So it becomes for 1 kilometer it is 1 by 3 hour. Therefore for 5 kilometers what is the time? It is 5 by 3 hour. As I want to convert this in minutes, 1 hour is nothing but 60 minutes. So I am replacing this hour by, that is 1 hour by 60 minutes here. So again 3 and 60 they cancel and finally here the answer is 100 minutes. So the tank will be filled in 100 minutes. Am I making clear? So here the core concept is there is a pipe which fills the tank. So in order to fill the tank, obviously the volume of the pipe should be equal to the volume of the tank because it fills. So the main thing to be highlighted here is you should know to equate the volume of the pipe to the volume of the tank. Once it is done, you know the parameters. The next thing is you have to calculate the time. Once you know the length of the cylindrical pipe, it will be easy for you to find the time taken. That is the main reason why we are calculating the length of the pipe. So here it is clearly given 3 km per hour. That is for 1 hour it is 3 km. Then what about for 5 km? So here comes the answer 5 by 3 hour. Again in order to convert this to minutes, I am replacing this hour by 60 minutes. So once it is done, here the answer is 100 minutes. Right. So that's all. If you have any doubt, let me know in the comment section. Thank you.